In a previous video, we looked at the graph of y equals x squared, then y equals x squared plus 1, which move x squared up by 1 unit, and y equals x squared minus 1, which move x squared down by 1 unit. We had also look at the graph of y equals negative x squared, and we make this negative, and what happened? Each line, each point is reflected over the x-axis, right? So whatever was positive becomes negative. Let's make this positive again, and we have it like that. What we want to do, let's erase these other graphs, right, and make some more adjustments to our y equals x squared. We have seen that y equals x squared plus 1 moves it up, y equals x squared minus 1 moves it down. But suppose we do a graph of y equals, and we come into the square part and we say y equals x plus 1 squared. What would happen? Well, let's see. I want to plot x plus 1 close bracket to the power of 2. That's what we had. That's what we have. Let's make this green, and let's make it thicker, and I want to see the label of the graph. Good. It says g of x is x plus 1 squared. Now you notice what happened? The x plus 1 squared move the graph to the left 1 unit, right? Let's put back y equals x squared plus 1. If we have x to the power of 2 plus 1, x squared plus 1 move the graph upwards 1 unit. Let me put x squared plus 1 in what? Red, just for comparison, right? Y equals x squared plus 1, and let me change my ink to the color red and write y equals x squared plus 1. So y equals x squared plus 1 is the red graph. Now look at the difference. X squared plus 1, all we're doing is adding 1 to x squared, and it moved the graph up 1 unit. But x plus 1 squared, now we go into the square part of the graph, and it's a matter of moving the graph sideways now, horizontally, and x plus 1 squared move the graph to the left, right? And it moves it 1 unit. Suppose we do a little thing here. Make an adjustment to our green graph, and instead of plus 1 squared, let's make it plus 2 squared. It moves x squared 2 units horizontally to the left. You see what's happening? Alright? But anyway, let's put it back now to 1 squared. See if it goes back. Good. So what it does, it moves each point to the left 1 unit. Alright? Let me change the color of my ink back to black. So here. X plus 1 squared moves each point horizontally to the left, 1 unit. Why does it move it to the left instead of to the right? And it's plus 1, right? Well, you can imagine that if we should consider the green graph and we want to move it back to match the black graph, our x squared, we would have to add 1 to each point. So we consider each point here as x, we'd have to add 1 to it for it to go back to the original value. So here would have to move back to here. This point would have to move 1 unit to the right, 1 unit to the right, alright? So y equals x plus 1 squared moves each point horizontally 1 unit to the left. Suppose we make a little adjustment here and we say we want y equals x minus 1 squared. What would happen? Y equals x minus 1 squared. Let's do that to the red graph. Let's change it up. Open bracket, x minus 1 close bracket raised to the power of 2. Look at what happened. The red graph is y equals x minus 1 squared, and it takes y equals x squared and moves each point 1 unit to the right. So x minus 1 squared, that's what happened to it. Alright, so there we go. Suppose we say x minus 2 squared. It moves it 2 places to the right. And if we say it's x minus 3 squared, it moves it 3 places to the right. Right? Now, let's put it back as x minus 1 squared. And there we have y equals x minus 1 squared. Alright? Now, suppose we look at the x plus 1 squared and we expand it. Let me put back my ink in green. We have x minus 1, x plus 1 squared. This is x plus 1 times x plus 1. So what we have is x squared plus 2x plus 1. That's what we would have, right? Now, x squared plus 2x plus 1 is the same as x plus 1 squared. If you have this one originally, the x squared plus 2x plus 1, what you would need to do is complete the square to get x plus 1 all squared. Now this will tell you that x squared is moved 1 place to the left, and you can sketch this graph, right, without having to calculate the value of each point. This tells you that it looks like x squared, and you add you move the graph 1 place to the left, right? So this is really the graph of x squared plus 2x plus 1, the green graph. And this clearly tells you what happened to the graph, so you can picture the graph in your mind and then sketch it. Alright? Now, as for x minus 1 squared, let me change my ink to red and go back to it. X minus 1 squared is really x squared. No, x minus 1. What am I saying? It's really x minus 1 times x minus 1, which is x squared, minus 2x plus 1. Right? So if you get this originally and you complete the square to get this, then this tells you, gives you a clearer picture what the graph looks like. It looks like x squared. Once you remember what x squared is, you just draw or sketch x squared one move, so that you move it. You sketch x squared and then you move it one place to the right. So this is really x squared moved one place to the right. Alright? Now, let us take a break and end this video here, but we'll continue this same topic in another video.